Hello everyone, welcome to Basics e-learning.
In lesson number 5 video, I am going to explain problems on mesh analysis. The previous 4 lectures on network analysis is also there in the channel, the link of which I am going to give in the description box. Please check it out. Also, there are lectures on signals and systems, basics and its numericals, Z transforms and problems on Z transforms. The link I am going to provide in the description box. All the questions that I have selected in all my videos are from previous question papers. Also, students who need online classes can contact us through the mail ID mentioned in the description box. Please go through. Let us see the first question. For the circuit shown in the figure, find the current through 30 ohms resistance using mesh analysis. So mesh analysis is based on KVL, right? Kirchhoff voltage law. So let us see. First try to find out the number of meshes in the given circuit and mark the meshes. Let us say here A, B, C, D, E, F, G, H be the nodes, right? So I can find 3 loops A, B, H, A, B, G, H, A, and the second loop is B, C, F, E, B, C, F, G, B, right? So this is loop number 2. Then this is my third loop, that is C, D, E, F, C. Or else without nodes also you can mark simply as loop 1, loop 2, loop 3. Loop analysis or mesh analysis. So these are the 3 meshes I have. Now let us say the current that is flowing in the first loop be I1 and second loop be I2 and the third loop be I3. Now coming to the solution part, let us apply KVL on all the 3 loops. So the equation in loop 1 here gives me, if you start from the part A, node A, then A to B, right, the current flowing is I1 and this is 15 ohms. So the sum of voltage drops and the EMFs should be equal to 0. So this is nothing but minus 15 I1. Again coming to BE node, BG branch, I have 2 currents flowing, that is I1 and oppositely it is I2. So that is minus 20 into I1 minus I2, then minus 2 plus 100 is equal to 0. See here, minus 15 I1 is for the branch AB and minus 20 I1 minus I2 is for the branch BG, and then GH I don't have any element. So H to A I have minus 2 plus 100, so that is plus 100 is equal to 0. So let us simplify this one. Minus 15 I1 minus 20 I1 plus 20 I2 plus 100 is equal to 0. So minus 35 I1 plus 20 I2 is equal to minus 100. So more simplified form, you can write this equation as 35 I1 minus 20 I2 is equal to 100. I just taken that minus out. So this is my equation number 1 here from loop 1. Similarly, write the KVL in loop 2. So from B, C, F, G, B loop, what I am getting, that loop 2 equation, you can write it as I have here 5 ohms. The current flowing is I2 minus 5 I2. Again from CF branch minus 30 into I2, right, minus I3. Then here I don't have any element, and then BG again 20 ohms. This I2 and then I1 is flowing in the opposite direction. So you can take it as I2 minus I1, that is 5 I2 minus 5i2 and then minus 30 into i2 minus i3, then minus 20 into i2 minus i1. So let us write that, and then, so let us write that loop 2, that is minus 5i2 minus 30 into I2 minus I3 minus 20 into I2 minus I1 is equal to 0. So this will be minus 5I2 minus 30I2 plus 30I3 minus 20I2 plus 20I1 is equal to 0. So you can combine all the common terms, that is I have only one I1 term 20 I1 and I2 I have 2 and 3 here, right? So that is totally 30, 20 and 5 minus 55 I2 plus 30 I3 is equal to 0. This is my loop 2 equation. So call this as equation number 2. Now you have to apply KVL for loop 3, right? So let us see what is loop 3 equation. So here in loop 3, I have C, D, E, F, C. So from C to D, I have an element 5 and the current flowing is I3. So this is minus 5 I3 plus 2 minus 100. No element here. Then minus 30 into I3 is flowing along with the path and I2 is flowing in the opposite direction. So minus 30 into I3 minus I2, that is equal to 0. So write it down and simplify the third loop equation also. So I'm writing it here. Minus 5i3 minus 100 minus 30 into I3 minus I2 is equal to 0. So let us simplify. Minus 5i3 minus 100 minus 30i3 plus 30i2 is equal to 0. So I don't have I1. So what I have is 30i2 minus 35i3 is equal to 100, right? So this is my third loop equation. So once you got the three loop equations, now we need to simplify these three equations to get the three unknown values, that is I1, I2, I3. These three are nothing but the loop currents. I have rewritten the three equations here, and let us start solving the three equations to get the three unknowns. The simplest way is using Cramer's rule, that is the matrix method. So let us write them in the matrix form. Here I have first is I1 35 minus I2 coefficient minus 20. As I don't have I3 coefficient in the first equation, I am writing it as 0. From the second equation, let us write the coefficients of I1, I2, I3. Again, from the third equation, let us write the coefficients of I1, I2, I3. I don't have I1, so 0. I2 is 30. I3 is minus 35, right? So this is multiplied by I1, I2, I3, and that is equal to 100, 0, 100. So first try to find out the determinant of the matrix. So that I am finding out the determinant, that is equal to, so you take plus minus plus, so 35 into minus 55 into minus 35 minus 30 into 30, right? This part cross multiply, then minus of minus plus 20 into 20 into 35 minus 30 into 0, so anyhow that is 0 plus 0, so that no need to calculate, right? So now if you simplify this calculation, what you are getting for the determinant is 21875. So to find out the value of I1, we have to find out d1 by d. So to get the value of D1, replace the first column with the value 100, 0, 100. So let us do that. So then I'll get that determinant value D1 will be 100, 0, 100 and then minus 20, minus 55, 30. Similarly 0, 30, minus 35. If you want I2, you have to replace the second column. If you want I3, you have to replace the third column. So in the question, they have asked you about the resistance, that is the current flowing in 30 ohms resistance. So no need to calculate I1, I2, I3. All the resistances, all the currents no need to calculate, as 30 is involved with I2 and I3. So only calculation of I2 and I3 is enough to find out the current through 30 ohms resistor. So let us find out I2 and I3 now. As I2 is equal to D2 by D and I3 is equal to D3 by D. So the D2 determinant and D3 matrix determinant that you can get by replacing the second row and second column and third column. So let us do that. D2 will be 35, 20, 0. Then I have 100, 0, 100. Then I have 0, 35 and minus 35 from the matrix, right? So solve this determinant. I will get minus 35,000. Similarly, D3, the third column you have to replace. So 35, 20 and 0. Minus 20, minus 55, 30. So just replace the third column with 100, 0, 100. So solve this to get the value of D3. So I am getting minus 92500. So to get the value of I2 and I3, already I have calculated D determinant. So that you just do, this is the determinant value 21875. So I2 is nothing but minus 35,000 divided by 21875. I3 is nothing but minus 92,500 divided by 21875. So let us do the calculation for calculating I2 and I3. So here I2 is equal to D2 by D, that is nothing but minus 35,000 divided by 21875. This you will get approximately 1.6 amperes. Anyhow, I have minus, so the same minus I am writing. D3 by D, I3, that is minus 92500 divided by 21875. This you will get approximately minus 4.2285 ampere. So after finding the value of I2 and I3 here, we have to find out the current that is flowing through this 30 ohms resistor. So the current flowing here in 30 ohms resistor are 2, that is I2 and also I3. I2 is flowing in the same direction, whereas I3 is flowing in the opposite direction. So the current in 30 ohms resistor is nothing but I2 minus I3. So that you can do minus 1.6 minus of minus plus 4.2285. So the value you are getting here is 2.6285. That means the current is flowing from node C to F is 2.6285 amperes. So the assumption that we have assumed for the current direction is also correct, as you are getting positive sign. No problem if you are getting negative sign also, means the direction that you have assumed is wrong. That's it. Coming to the second question. In the circuit shown, use mesh analysis to find the power delivered to 4 ohms resistor. So here is the 4 ohms resistor. So let us quickly mark all the nodes here. So A, I'm taking B here, C, D, E, okay, F, E, G, F, G, H, right? So now, if you see here, you have current sources present here. So if you have current sources, then the mesh analysis is difficult, right? So you have to go with the super mesh analysis, right? So let us see the steps. So first you have one branch here AB. So in this branch AB, the current flowing is 2 amperes. Let us mark the currents also. Suppose say here this is I1, this is I2. Let us say this as I3. Go with the same direction, I3. So let us mark first, then we'll see accordingly we can convert that into super mesh. So as the current that is coming from this branch is I3, that is equal to 2 amperes. So directly we can say one branch current I3 is equal to 2 amperes, right? So again you have another branch here DG. Again this DG is also having some current source 5 amperes. So what is the current that is present in this branch DG? These two currents, I2 and also I1. See here, I2 is going in the same direction as this 8 amperes, whereas I1 is flowing opposite to 8 amperes. So I2 minus I1 is equal to 8 amperes. Now you can apply KVL without touching the current source. Any loop you can take without touching the current source, so that you can choose this way. I think C, D, E, you go with the super mesh. H, G, F. Now you can get, see, C, D, E, H, G, F, C again, right? So that you can do. So 1 ohm, the current flowing here is, and moving in this direction, as the current is also moving in the same direction, you can take it in the negative. So minus I3, and then I have here minus of the two currents that are flowing in this 1 ohm are I3 and also I1. So minus of I3 and I1, that you can write minus 1 into I3 plus I1. Both are going in the same direction. Again here coming to 3 ohm, in this I have I2 and also I1. I2 and also I3, both going in the same direction. Again you can take minus I3 into I2 plus I3. Coming to 4 ohms resistor, I have only I2, so minus 4 I2. Again from here minus 2 plus 24 ohms is equal to 0. Now let us simplify this. To get the current that is flowing in, only 4 ohms resistor we need, I2 we need. So let us do that. So simplify, minus I3 minus I1 minus 3I2 minus 3I3 minus 4I2 is equal to minus 24. But we have that value of I3 we know here, that is 2 amperes, that you just substitute here. And also we know I2 minus I1 is also 8 amperes. So let us put I3 value here. I3 is 2 amperes. So minus 2 minus I1 minus 3I2 here minus 3I3. So that is 6 minus 4I2 is equal to minus 24. So let us combine this I2 term. Minus I1 minus 7I2 is equal to, this is 8. So minus 24 plus 8, right? So more simplified here, you can take only I2 value I need. So here I have I2 minus I1 is equal to 8 amperes, means you can substitute everything in terms of I2, no? So that is I1 is equal to 8 plus, sorry, I2 minus 8. So let us put this here. I1 place I am writing minus of I2 minus 8, right? So that minus I2 minus of minus plus 8 minus 7I2 is equal to minus 24 plus 8. This 8 anyhow will get cancelled, right? Minus 8I2 is equal to minus 24. And that means I2 is equal to 24 by 8, 3 amperes, right? So once you get the value of I2, that is the current flowing through 4 ohms resistor, let us check the question again. They are asking you to find out the power that is delivered to 4 ohms resistor. Means the power is I square R. So power in 4 ohms resistor is equal to I square R. So the current is 3, right? 3 amperes. So 3 square is 9. 9 into 4, that is 36 watts. So in this way you can simplify this problem very easily using super mesh. Whenever you find the current sources, find out the mesh that is not touching the current source, that we call it as super mesh method. Let us see the third question. Write the mesh equations for the circuit shown and determine the mesh currents using mesh analysis. So this is the given circuit. If you observe here, we have a current source here. So because of this current source, before applying the KVL itself, understand the currents, that is the mesh currents. See here, let us call the first is I1. In the second loop, let us say it as I2, and in the third loop, call it as I3. So if you observe in the first mesh, the current I1 that we have assumed is coming out from the current source 10 amperes. So directly we can write from the first mesh I1 is equal to 10 amperes. So all that we have to find out is only I2 and I3. So we have to write KVL along these two loops. So for more clear understanding, you can mark the nodes also. A, B, C, D here. You can take E, F, G, H. So the remaining two loops here are B, C, F, G, B. See, that is the second loop here what I am showing. B, C, F, G, B. So write KVL along this loop. So from B to C, as there is no element, nothing to write. Again from C to F, I have two elements, one resistor and one voltage source. In this 2 ohms resistor, the currents that are flowing are I2 and I3. So as the current is flowing in the direction as you have assumed, so directly you can take it minus I2 into I2 minus I3. I2 and I3 are flowing in the opposite direction, right? So then plus 2 minus 10 volts, right? Again, F to G, there is no element. You can write from G to B. So in G to B, I2 is flowing along with the direction and I1 is flowing in the opposite direction. So that you can take the drop minus 3 into I2 minus I1 is equal to 0. So let us simplify this one. So minus 2I2 plus 2I3 minus 10 minus 3I2 plus 3I1 is equal to 0. So what I am getting here is 3I1. So I1 value you can put it here. I1 is equal to 10 amperes, that you can substitute here. So substituting I1 value in this equation, what we are getting is minus 2I2 plus 2I3 minus 10 minus 3I2 plus 30. I is 10, no? So is equal to 0. So I have two I2 terms. So let us simplify this. Minus 2I2 and minus 3I2. That is nothing but minus 5I2 plus 2I3 plus 20 is equal to 0. So that I am taking it to the other side. So minus 20. Let us call this as first equation. Now consider the second loop and write down the equation, that is along C, D, E, F, C. So again the current that is flowing in 3 ohms is I3. So this comes to minus 3I3 minus 2 plus 10 volts, and in this 2 ohms resistor I3 minus I2. So minus 2 into I3 minus I2. So let us write down the equation. So I am writing it along C, D, E, F, C. So the loop equation will be minus 3I3 plus 10 minus 2 into I3 minus I2 is equal to 0. So there is no I1 term, no need to substitute. Directly you can simplify this. Minus 3I3 plus 10 minus 2I3 plus 2I2 is equal to 0. So this is nothing but 2I2 minus 3 and 2, 5 minus 5I3 is equal to 10. You take it to the other side, minus 10, right? So these are the two equations that I am getting from the given circuit. So let us simplify these two equations. Both the equations are in terms of I2 and I3 only. You can simply solve the equations using equation solving method, or you can go with the matrix method. Anything is fine. Let us see. So these are the two equations that I am getting. You can solve these two equations either by equating the coefficients or by using matrix method. So as a token of practice, I am just using the matrix method. So write down the determinant here, that is minus 5, 2, 2, minus 5. So the determinant is AD minus BC here. So minus of minus means that will be 25 minus 4, that is equal to 21. So let us find out D2, as we need only D2 and D3. D1 we know, right? So in place of this first you can write it in the matrix form also for more clear understanding. I2, I3 is equal to minus 20 minus 10. To find out, so let us find out D2. So D2 is nothing but you have to replace the first column with minus 20 and minus 10. So let us do that. Minus 20 minus 10 and then 2, then minus 5. So simplify. This will be minus of minus plus 100, right, plus 20, that is equal to 120 here. AD minus BC here. Then again to find out I3, we have to calculate the determinant D3. So for this you have to replace the second column with minus 20 and minus 10. Let us do that. Minus 5, 2, minus 20 and minus 10. So that is equal to 50 minus of minus plus 40. Right, that is equal to 90. So to calculate I2, that is D2 by D. Similarly I3, D3 by D. Means here it is 120 by 21, whereas I3 is 90 by 21. So if you solve this, you will get 5.71 ampere. This you will get it as 4.28 ampere. So these are the two values of I2 and I3. And from the circuit directly we found the value of I1. So simplifying the meshes given big circuit using KVL and mesh analysis, we can find out the loop currents easily.
For more videos, please do like, share, subscribe to our channel. Let us know your suggestions and queries in the comment box. Thank you.